Okay, so it will be like this. We are going to sketch this one without any chamfer. As I mentioned to you yesterday, we ignore the chamfer, so the shape will be like this. Like this, this shape itself. Okay, class. So I will return back. I will stop sharing this one. I will open up my inventor. Okay, come on, return back to here. Okay, so please open up the new file for new parts file. So ensure that you are using the correct project files that you have just created yesterday. So everything later you can go to this folder itself, okay, to actually upload the exercise into the CDOS. Today one, I would like to require you to save the parts file, then you upload into the CDOS in the exercise, the folder exercise. So later I will brief you on that. So template matrix standard mm.ipt. So just go create like what actually your friend did just now. Okay, so wait a few seconds. Okay, so we are going to start using a work plan. So go to start 2D sketch, please. 2D sketch. So as usual, if you have your first sketch, okay, then you have this default work plan here, default work plan ready for you. So you can select any of these plan to become your work plan. So I would like to select this one, XY plan. Okay, so we are going to create our initial sketch here. So what I would like to do will be, I would like to utilize a simple shape, which is rectangle. So I will show it to you. Show it to you. Please have a look on it. Okay, so rectangles, again, it's a 2-point rectangles. So I have to create my sketchings like this. First one here, and then I have a subsequent one here. You will see you have one line guiding you, right? So if you click now, then you will pre-apply what you call the this constraint, collinear constraint. So you can apply this one here, then up to here. So you see, okay. And the next one will be, okay, I would like to create a rectangle also starting from here, the endpoint of here, which if I click now here, you will be applying what you call a coincidence constraint automatically. So from here, snap to endpoint here, drag one to here. Similarly, endpoint here, snap to here again. Okay, so if now I want to apply the collinear constraint, then you can click. If no, you can always do it later, no problem. Click here. Okay, then another one will be like this. So in a total, I would like you to have 5 rectangles for this initial sketch. Okay, 5 rectangles. Then I would like to escape. Okay, so that is our initial sketch. I will give you a minute for you to do it. So please try to create these 2-point rectangles. to be approximately like this, approximately like this. So I give you a minute from now.
Yeah. Sir,
Yeah.
can you repeat again because hello?
Yeah, sure. I can hear you.
Okay. Can you repeat again, sir? Because saya terkeluar tadi.
Okay. So I will delete this one again. Okay. What I would like you to do will be you go to 2-point rectangle. 2-point rectangle. Try to create a shape like this. Okay, you have one rectangle here, another rectangle here. If you have one line here, you see the guiding line, correct? This is collinear constraint. So if you click now, that means the left and my right hand side, like the horizontal plane, it will be the same. So if no, you don't to utilize this one, then you can create one like this also, no problem. Okay, but the next one, the most important one will be I would like to create another rectangle to snap towards this endpoint here. Okay, here another one here. Okay, another one over here also. Okay, and last and for all, another one over here. Okay, please create these 5 rectangles. Then we are going to try to apply the geometrical constraint to stabilize the shape before we apply what you call the dimensional constraint, as what we did yesterday. Okay, class, please go to try to create these 5 rectangle. Okay, any problem?
No, sir.
No, okay, so I think most of you are able to do so. Okay, next one will be, as I say, we must always figure out which one will be the best geometrical constraint here to stabilize here first. Okay, so you will see this particular axis itself, and here they are supposed to be collinear, right? Just now, if you don't click apply the collinear when you actually create your rectangles, then we can apply it manually lah. Okay, but just now if you have followed the collinear, just now if you have the blue line here, then actually you click on this point itself, then you already actually apply the collinear constraint to this geometry. Okay, so it's no need for you to reapply again lah, or else it will be over constraint. So if mine want this one, because just now I purposely I don't use the auto constraint, right? What you call the auto constraint. So collinear, I go apply it manually now. I will like this line and this line, same collinear axis. They have the same axis here, horizontal axis. Similarly, I repeat. Similarly, I would like to repeat to here, this line itself. Okay, the bottom line here and the bottom line here. Okay, and then maybe this one also, they can have the collinear constraint. So this one and this line. So in a total collinear constraint, I would like you to apply to the top line here and then the bottom line here. Okay, bottom and bottom, of course. You don't click this line and this one. Later it will tilt over one side. Okay, and then this line here and the line on my left hand side here. Okay, class. So far, any problem?
No, sir.
No.
No,
Okay.
sir.
Next one, we would like to trim. So I think you should be familiar with trim, right? So we got to modify it here. You can see trim here. Trim. So trim is very direct. Actually, we just erase the unwanted lines. Okay, so you go trim, please. Please go to trim. I would like to trim off this line here. Just click on the unwanted line here. Okay, this one, trim, click, just click. Click, click, click and click. Okay. So that is trim command, very direct. Go to trim, then click on the unwanted line. Okay, so if you're able to refer back to the drawings, your drawing here, okay, so we already more or less get the shapes that we want already. Where's my drawing? I can also share this one. Okay, you see this front view, right? Is the front view here. So there's the shape. That's the approximate shape that we would like to obtain in our sketch. Okay, I think it's stable enough already now. Okay, so we have this here already. So the next one, after you have applied the geometrical constraint, okay, we assume this one is stable enough already. Okay, so we would like to go back to, we're going to apply dimensional constraint. Okay, dimensional constraint is pretty straightforward. Go to dimension here. So the first dimension that I would like to show to you will be here. We know that from this top line to this line here, it will be 20. It will be 20. Okay, so I would like to apply from this line to this line. The current one is 81.859. Okay, we'd like to change it to 20. 20. But you will see it shrink. It will shrink. Okay, since just now it's 80, now it's become 20. Okay, I would like to repeat to you again how you can actually apply this dimensional constraint. Clicking two lines itself. Line and line. So 20, the first one. Another method that you can apply the dimensional constraint is by clicking on one single line. For example, that we know this particular line here, this bottom line here, this bottom line, this whole length, green one, okay, is 15, right? So you just go to dimensional constraint, referring to this line only, one line only. One line, click. So you can apply 20. 20, yeah? Okay, similarly, you know that this line also, accordingly to the drawing, will be 5, right? 5. Okay, so I already showed to you two methods. One is by clicking on the line itself. One is by clicking on two lines. The 1, 2 lines will be like this. Repeat. Okay, we know that this line here, okay, and this line here, it will give you the value of 7.5. 7.5. We know that these two line, This one will be 4. 4. Okay, and then we know that this top part here is 5. Okay, I would like you to create, okay, apply the dimensional constraint on left hand side or right hand side only. You just select one side only. Later, I will brief you on what to do next. Okay, I will give you a minute to try. This one, you will see it's supposed to be a line, right? Okay, later we will amend this. Okay, stabilize this condition. No worries, no worries. And then we know this one also 20. Okay, sorry, this one is 15, right? Okay, this one you see it will turn this side. Okay, so I don't apply this one first. This one is 15. Okay, I will let it remain like this.
So I'm having problem with the one on the bottom, 15 millimeter.
15. Then what happened to yours?
I don't know how to explain. Can I present to and show to you?
Okay, sure. Back further. Okay, I think I already set you as the presenter. You can present.
Yeah. This can you see it?
Yeah.
So when I want to change to 15, it becomes like this.
Okay. Actually, not a problem there lah. Okay, you can actually drag the top line there to join up.
This thing.
Drag to the left. Can you drag to the left? Drag again. To the left again. You don't apply that one. You undo first. You drag to the left hand side. Drag until it overshoot the 15 line. Yeah.
This one. Okay.
Yeah. Okay. Yeah. Okay. You get the shape back, right?
Yeah.
And okay, and then one more will be okay. One more will be
So do I need to remove this line, the one that is outside of 15?
you need to apply coincidence constraint. Endpoint to the endpoint. Yes, that endpoint on your right hand side there, and towards the 15 endpoint.
This one?
Yeah. Coincidence. You go to coincidence constraint, please. Yeah, that one.
This one. Okay.
Correct. Endpoint.
Yeah.
Okay. Okay. Snap towards the the endpoint there. Click. Fail to add
Add constraint. Points lie on the same curve.
Okay, maybe you cancel first. You delete the 15, the dimension of 15. Escape. Okay. You press escape first. Escape. Yeah, you go delete that. Okay. Now you try to. Can you try to drag from the endpoint there to the left hand side also? Yeah, you try to drag.
This one?
Yeah. Drag. Okay. Yeah, correct. Fail to create constraint. Okay, cancel. Try to trim this off. Is it possible to trim?
Yeah.
Yeah, okay. Then you go apply.
The dimension.
Yeah, the dimension 15.
Okay. I'll stop presenting first. If there's any problem, I'll ask you again.
Yeah, sure. You try that one out. Okay, class, the rest of you. I think I should give you times for you to digest whatever that I. Okay. So no problem. Just now because of the redundant line, I think. Okay, so you try to get these shapes and dimension. Okay. So mine one also, you see this one, you have another line here. So actually you can delete that particular line. Okay. So I just leave it like that first. Okay. You see another line because just now we create two rectangles here, right? So you have redundant lines at this part here. So it's the best you delete the line itself because you have another line here, which is more relevant to the shorter one. Okay, you see? Okay, plus you try to get this shape, okay, and try to apply the dimension as close as possible to this. I think I miss out another one here will be 10. Yeah? Here will be 10. Okay. So you will see once I already apply all those constraint, dimensional constraint plus with the geometrical constraint, it will stabilize the shape on the left hand side itself. Right? It will actually stabilize the shape on the left hand side. Okay, I give you 2 minutes, 2 minutes on this. If any one of you encounter any problems, please ask.
Sir,
Yeah.
after we finish the dimension tu, kita boleh buang dimension tu ke atau biarkan saja?
Kita biar saja. Kalau you delete dimension contohnya macam ni lah. You nak delete kan. Then actually ini bukan 4 lagi. Dia boleh move up. You see? Move upward down. Kalau kita apply dimension, if you apply here 4, right? Then actually you see we lock this into their position. It's remain 4 lah. No matter how we move it.
So it's okay if like the dimension is quite mess. Like
You mean the placement of it like this?
yeah,
Yeah, it's up and down and so on.
yeah. Is it okay if we just
It's okay, no problem. No problem on that.
okay, thank you, sir.
Okay.
Sir, bukan ada satu lagi line ke sir dari top pergi tengah-tengah tu sikit. 7.5.
7.5 mana tu? Itu chamfer kan? That one is a chamfer. That one is a chamfer. Later I will show to you again.
Okay, sir.
Okay, a very good questions. Okay, you see 7.5 here, right? Okay, this is a chamfer. So as I mentioned in Inventor, if it's involved chamfer, or holes, fillet, shell, and so on, we ignore it in our sketching. Okay, kita abaikan. We ignore it. Later you will see how we are going to add these added features. Added features is relatively easy. So we are going to do that towards the end of these progressions. Okay, so I assume all of you already get the shape. Okay. Okay, next one you will see. Okay, just now we know that you will see this line and this line. They are supposed to be at the same vertical axis. Do you agree on that? It's supposed to be the same vertical axis, right? So I think we miss out that constraint. You think that if you miss out the geometrical constraint, then you can go apply it again at any time in Inventor. So I would like to go to Collinear now. Collinear now. Okay. Then I would like to reapply the geometrical constraint, which is this line and this line. So I just go to click here and click here. You will see there will be collinear lines between these two lines itself. Yeah, collinear. Okay, next one that I would like to share with you will be, normally if you have a symmetrical drawing, which means top and bottom same or left and right, they have the same dimensions. Okay, so what you like to do will be, you don't want to reapply the same dimension. It's very easy and straightforward actually. You can go to dimension and then you put in 5, 20 and so on, right? But if you want to avoid doing the redundant work like that, what you can actually do is to utilize the equal constraint. Okay, you can go to apply equal constraint. So I would like you to try on this. Since I already stabilized my dimension on my left hand side, I want to apply equal. Equal. So you know that this line and this line, they are equal, right? They have the equals dimension. So go click on here, click on here. Equal, then apply. I know that this line and this line will be equal. Okay, so if you see this constraint, the dialog box popping up, over constraint, that means it's already noted that 20 here is also 20 already. Since we just now we apply what you call the collinear constraint to this line, right? So it will lock at 20. So this one just cancel. Okay, cancel. So just go to equal again, then which equal? The bottom line here. Bottom line here, right? The long line, not the shorter line. As I say, we have redundant lines there. Actually, it's the best we delete this shorter line. But if you want to leave it, also no problem. So equal, is it? We have equal here. Another one will be, which one? Do you think our geometry is stable enough already? Maybe here? And here? Over constraint, that means since we already apply the collinear between these two lines, I think this one is locked at 5 already. Okay, I think I should have the correct dimension already on the both sides. Maybe here, in here. Yeah, also over constraint, so should be stabilized already. Okay, so please have a look on your geometry. Is it stable enough? That means if I drag, if I drag on any point, okay, it won't change shape. Okay, now here is 20. Okay, we yet to lock this the gap to become 20 actually, yeah. So what I would like to do next will be I would like to turn this one into 20 lah, 20. The distance will be 20, right? So the last dimension that we need to perform is this gap here. This is 20. Okay, this is 20. I think should be good enough. Okay, this one, as I say, we just delete that. Okay, you just ensure that it's stable. No matter how you move it and so on, you should get the shape will remain the same. Okay, that means we have a stable sketch. Okay, class, I give you 1 minute to finalize it. So if you would like to have a look on the constraint that you already apply, okay, so right hand click and show all constraint, or I've add. Okay, equals, you have a lot here, which if you draw, you create using the rectangles, then you have the pre-applied constraint. So since it's very messy, you should, we always hide on constraint lah. Okay, then we only turn it on if you want to do any editings on that. Okay, any problem? If no, I'm going to finish sketch to exit the sketch ribbons.
Sir, how to move the base layout, sir?
How to?
Move the sketch.
Just left hand click on points or whatever lines that you want, then you can drag. Left hand click. It is okay, sorry. This is the line, if line, left hand click all on. If point,
Sir, what if our sketch like doesn't constrain the lines, all of the lines doesn't constrain? Some lah. Some of the lines didn't constrain.
you can go reapply manually. If those lines are not properly constrained, you can apply manually whatever appropriate constraint that you feel that it will stabilize your geometry. You go, for example, you don't have, this one is not the horizontal plane, right? So you go apply horizontal. If this line is not in the vertical sense, then you go apply vertical constraint.
Okay, sir.
Okay, so I think most of you already get your geometry, okay, your profile to be stabilized, okay, in a stabilized mode. So we sketch, okay. Alicia, have a problem. So okay, never mind. You can, as I say, you can always refer back to the YouTube later. I will try to do so. This is the first time I try to upload something in the YouTube and so on. It's a how to say, learning lessons for me as well. Okay, learning process. Okay, so I just finish sketch. Okay, so once you finish with your initial sketch, so for the rest of you, if you're able to follow, then just follow through. Okay, we tried our best to get our desired outcome. Okay, so once you finish with your sketch, so as I say, this is a single sketch features, single sketch. So what I would like you to do next will be you go to Extrude. We are going to perform Extrude. So if your profile is properly is a step in a stable mode and is in a closed loop, So closed loop means no discontinued lines and so on. It's closed up. First point and end point itself. Okay. So supposedly you will have the profile been selected automatically. Okay. So it's very direct. Once your profile has been selected, what we need to define will be the behavior wise and the distance. Behavior will be the direction. So direction normally defaults in this sense will be no problem in this case. So distance wise, we will put in, what's the distance? Accordingly to this drawing given here will be 30. Okay, will be 30, yeah. So I just return back to here, 30. So distance here, please amend from 10 to 30. Please put in 30, yeah. Click OK. So you can see we have our best features here now. So you can use your view cube to navigate with your view. It's the best you know how to navigate well with your view. Okay, 2D. Okay, return back to home, isometric drawings, and so on. Any one of you have problems on that?
Lagi boleh kan?
Yes, I cannot hear you clearly.
Repeat sir. Lagi.
Okay, I will go back to my sketch. After you have finished your sketch, right? You click finish. Finish your sketch, then you go to extrude. The commands that we are going to perform will be extrude. So as we mentioned, if you only have one single profile is your sketch basically. So it will be automatically been selected. So if yours one is in closed loop, automatically it will be selected. Then the only input that we need to provide will be the distance. So distance will be 30 in this case. So direction, no problem. Direction you flip there or flip here, so it doesn't matter in this case. Okay, so we just use the default direction here. So the only input that you need to define will be the distance to be 30, then click OK. Then click OK. So referring back to our drawing here, you get this shape already, the base features. Alicia, are you in already? Are you able to reconnect? Okay, so class, no problem. Any problem, class?
No, sir.
No, sir.
Alicia, are you in? Alicia? No? Just now Alicia mentioned that she has a blackout, right? Then lost the data, then able to reconnect back. Okay, no, then I will just proceed. Okay, next one, you see, if you have a look on our drawing here, you have what we call a chamfer. And we have holes here. So for these added features, there is no need for us to have a sketch. Okay, we can just perform that features in the 3D mode. So what you can do is, we are going to do holes first. Please pay attention to this hole. The variables that you have, you are given the diameter for this hole is 6.5, and then you know that this hole center point placement will be 5 from this top line. Distance will be 5, and then it will remain at the center here, center of your between these two lines, right? Okay, midpoint between these two lines. So you know that it will be 30, so it's 15 Basically, it's 15. These two lines here. Okay, it's in between. So I will return back to the inventor itself. So holes is available at here. So if you have all these features, hole, filler, chamfer, shell, draft, and so on, no need for you to create sketch. Okay, no need for you to enter the sketch mode. So holes is over here. So please class go to holes. Click on holes, please. Okay, there are various type of holes that you can apply actually. Okay, the first one here will be a linear placement. What we call a linear placement here. So linear placement, okay, First thing, you need to define the surface you want to create the holes. As I mentioned to you earlier, right? Okay, if you are lost and so on, please pay attention to your status bar. Huh? So add a holes point, select a linear or circular edge to add a constraint. So first step will be to click on the surface you want to create your holes. So you can either apply the holes on this surface, or you can actually rotate this here, or on this particular surface. So it doesn't matter. It doesn't matter. So I just click on the surface. Okay, you will see a preview of holes here. You will see a preview of holes here. Huh? Okay, so I will go into zoom in into here. So when you click on that particular surface, you will see the placement of your holes. The center point of the holes is actually not at your desired location itself. So you need to define the placement of that center point. Okay, so how you can do so, this one is what you call linear placement. Huh? Linear placement, we need to provide two linear reference for that center point of the hole. Linear. So what you can actually select will be edges or lines. Huh? Edges or line. Okay, I would like to show to you, we know that this center point of this hole, we know that is 5, right? From this top line here. Just now I mentioned the distance will be 5 from this top line. So what I want to do is, I know that from this top line. So I click on this top line itself. Click. Okay, once you click, you see they will ask you to define. Okay, you want this center point from this top line to be 5. So key in 5 here. Automatically, you see that center point of that hole, it will shift up to 5 the distance. Automatically, it will shift up. Okay, this is only the first line. So as I mentioned, for linear placement, you need 2 reference lines. 2 reference lines. So another reference that we can give will be either you select the line on your left hand side here or right hand side. We know that it will always remain at the center, which is 15. So maybe I click on this side. So you will see current one is 14.544. So I will key in 15. 15. So top here, 5. This one, 15. That's the thing you need to perform. Okay. So please try on this. Okay, so if you have done that, the next one, please have a look on the behavior. As in Extrude also, I think you should know more or less if behavior-wise, what are the variables that you can configure inside here. So the first one will be termination. Termination here is a distance, basically. So if you want certain distance here, then you can click, then you can define the distance, okay, the depth of your holes. So in this case, we might select through all. That's the best. So it will penetrate from this surface through everything. Okay, through all. Or you have two. This means two-way. Okay, you can have two here. So you select through all for this case. Then direction. Okay, direction for this one, I think is the appropriate one already. We just remain this as default. The next one will be our diameter. Okay, so you can have a look on here. The diameter is here now, it's currently 6. then put in 6.5. 6.5, right? So as you say, you can see that if you change 6.5 here, so automatically here it will be updated also. So once you already define everything, then you just click OK. Okay, you will see that if I rotate here. Okay. Okay. That's the most that you want. So click OK once you have done that. Okay, class, any problem?
No, sir.
No?
No, sir.
Okay, very good. If no problems on that. Okay, next one that I would like you to try out will be chamfer. So if refer to the drawing here, the last part that we need to perform will be the chamfer on both sides. Okay, chamfer. So please look at the variables, okay, that you have for chamfer. You know that the angles will be 30 degree. Then you know the distance cut from this edge 7.5. This is the line 7.5 that you think that I missed out, right? So this is for the chamfer. Okay, so I will return back to my inventor here. Chamfer is over here. Chamfer. So for chamfer is also the added features. No sketchings needed. Chamfer straight away. Once you click on chamfer, you have the dialog box of chamfer here. So I would like to brief you on the type of chamfer that you can create. Okay, the first one will be very straightforward. You need to define your edge. Then you have distance, equal distance. So 2 currently, 2. That means it will cut. If I click here as my edge, it will cut 2 and 2 mm and 2 mm. Another one here is distance and angle. So once you change from distance here to distance and angle, they will ask you to define your face, your surface, and what are the distance here, then angle. Okay, so the variables will be accordingly to the type of chamfer that you define. Last one will be if you have unequal distance, you want to put in unequal distance actually. So what you can do is you can click on this. Then you have distance 1 and distance 2. So based on the drawing given to you, which one do you think is more appropriate to apply circumstances now?
Distance and angle.
Yes?
Distance and angle.
Yeah, distance and angle. Okay, so the one, because we have the parameters of distance and angle. So you need to select this. Distance and angle. The one appropriate, most appropriate. So go to define face then. You see, status bar, select face for chamfer. So the face that we need to define for this case will be either you can click on here. We need to create on both sides actually. One here, another one on the opposite side here. So I will perform it on this side first maybe. So face will be this particular face itself. So click on the face. So once you already define your face here, they will ask you select edges for chamfer. So which edges you want to turn them into a chamfer. So you will see it will straight away jump to here. No need for you to go to click on the edges. So it will be these edges and these edges itself. So you will see a preview of the chamfer there already. See a preview. Okay, then you need to define your distance. So your distance will be 7.5 lah. Just now we have chamfer 7.5. And we have the angle of 30 degree, right? 30 degree. So it will be 30 degree from this particular face here, 7.5. Okay, so that's the chamfer that we intend to have. So once you have done with all these correct value for the parameters or variables here, just click apply. Okay, we have chamfer on one side already. So please rotate. You can use the view cube. Okay, use your view cube to navigate with your view. So again, repeat the same step. Okay, for those who missed the first part of it here, I will like to repeat. For the chamfer type, you go to distance and angle and define your face. So face is over here now. Okay, so once you already define your face, it will be highlighted like this. Then you need to define, the next one will be the edges. You want to turn it into a chamfer. So edges will be here, this one and this one. So as you can see, once you select your edges, then it will be a preview there. Okay, is it correct that particular edges you want to turn it into the chamfer? And the next one that you need to define, of course, is the variables. Distance, please key in 7.5 is drawing, and you have the angle of 30 here. So once you already define everything, then you just click to apply. Then I think that's all. And that's it. Okay, so that is our drawing. The features that we intend to do for this particular exercise. So I will give you a minute for you to finish up whatever.
Sir, can you repeat, sir, for the chamfer?
For the chamfer.
Yes, sir. Yes.
Okay, maybe I delete this chamfer first. Okay. Of course, you can see from the browser, as I say in Inventor, it's very important for you to take notes whatever happened in the browser. So if you make a mistake itself, you can always delete it from your browser. Don't go undo. Okay, so I delete my second chamfer here. You will return back. You only have chamfer on the other side. Okay, so chamfer. So please go to chamfer. So for this one, please apply distance and angle. Distance and angle. So click on distance and angle, please. Okay, then they will ask you to define your face. Look at your status bar. Status bar on the left-hand side, bottom left-hand side. So this is our face now. Okay, make sure is once you click your face, it will be highlighted. Okay, then they will ask you to define your edges. Edges will be these two edges here. Click and click. Okay, so once you already select your edges, then the next one that you need to do will be, you need to provide a distance, which will be 7.5 in this drawing. And you need to provide the angle, okay, which is 30 degrees. So once you already do all this, then you click apply. Then you click apply, then please rotate your features to the other side, then you perform the same steps. Okay, define your face, select the edges, and then distance is will remain the same unless you change it. Apply. Okay, that's the chamfer there. Okay, hopefully you can get it this time.
Thank you, sir.
Yeah, no problem. Okay, class. I assume no others questions on this. Okay, so the next one that I would like to expose to you or share with you will be Okay, in your particular task or whatever later, especially this one is very useful in your project lah actually. Because in a project letter, the panel will normally ask you, your machine, what's the weight of your machine? Because if you claim that the objective of your project is to make your project is more portable and so on, so they would like to ask you the mass, okay? Mass or the weight of your machine. So what you can actually do is you can estimate that particular mass in this inventor wise. Okay, using this inventor. Okay, for the appearance of this, your features here, your parts here, you can change the appearance. Appearance is available on the top side of your bar here. What you call the QAT lah, Quick Access Toolbar. Okay. Quick Access Toolbar, you can see now is default, default as material. Here is generic. Okay, generic here is that mean we apply the material to your parts. Okay, so normally I will ask students to go to the appearance lah. Okay, so please click on the arrow here. You can see a lot of gold. Okay. Okay, then you have a lot of type of appearance here that you can change to. Dark, silver. Okay, so this is only the appearance. You want this part, the appearance to look alike like silver. But if you think that you want to change it to have that particular material property, then you should do it over here. Do it over here. Do it over here. Gold and so on. Then it will turn into a gold property using the gold property itself. Okay. But in our exercise actually, in our exercise and also practical task, you should ensure that your material here will be a generic form lah. Generic form. So what I would like you to do now is, I would like you to go to the browser, parts 1 here. All of you should have parts 1 lah, unless you open up second parts, part 2 and 3, because just now you make a mistake and you open up another parts file and so on. But no problem on that. Okay, please go to your parts browser here, right hand click please. Go to right hand click. Go to what we call I property. I property. Okay, in I property here, I would like you to go to physical. Physical tab. The rest you don't just ignore it. Okay, just go to physical here. As you can see here, here's the physical part of the information that you can obtain. Okay, so I would like you to go to update, please. Update. So as you can see, if the material is generic form, if it's at generic, that means we are using the density of the current value. So just go update, please. Click on update. Okay, so if you perform everything right with the correct dimension and so on, with the condition that material, you must ensure that it's in generic. Appearance, you can change, no problem. Appearance, but material, you must ensure it's a default generic. You should get the value of the mass here, 0.012 kilogram. Okay, provided you get all this correct, and the area is supposed to be this, center gravity will